Hey everyone, and welcome back to the Engineering Toolbox channel. So in a previous video I showed you how to create a simple IMR chart using Microsoft Excel. And that was cool and all, but as I said in that video, we can take that a step further. So for those of you who understand control charting, you probably already know that there are 8 rules that help us understand the process and whether or not it's actually in control or out of control. So in this video I'm going to show you how to set up your chart so that it dynamically formats and labels the data points if it violates one of those 8 rules. So let's just take a quick look at the end product here. So what I've done is I've set up this chart so that we have some conditional formatting going on. So any of the data points that fall outside the upper and lower control limits will be formatted in red. The in-control data points are formatted green. And then we also have these yellow data points as well that are data points that break one of the other 7 control charting rules. And then you'll also notice that I have data labels with numbers, and those numbers correspond to the rule that the data point is actually breaking. And I think what's coolest about this is that I didn't format this manually. This was all done automatically. So if I were to drop in new data into my table, this would actually reformat the points based on the control charting rules. So it all happens automatically and dynamically with the data. So going back to where we left off last time, we can see our charts and there's no conditional formatting. We just have a typical plain Jane IMR chart with our data points and the control limits and sigma levels and all that kind of stuff in there. First thing I want to do is I want to go back and point out that there was actually an error in my calculation. So the MR bar value should not include this first MR value. And that's because this first data point doesn't have a moving range. It's only one data point. It can't be a range of only one data point. So I was taking the average of all the data points, including the 0 value, so it was actually skewing our MR bar value a little bit. So what we want to do is set up this equation so that it returns a blank value if there's only one data point. So what I'm going to do is I'm actually going to delete this completely and just start from scratch. And remember, the goal with this kind of template or this document is to set up a data table and a chart that we can drop in any data into it and it'll automatically do all the calculations and set up the chart without us having to adjust any formulas or anything. So the only way to do that is by using offsets. And the reason we want to do that is so we can only use table references. And it's kind of hard to explain, but hopefully you're able to see kind of why we do this. So anyways, to set up this formula, we say if is number, and then I'm going to do an offset. And the way the offset works is you take a cell reference and then you tell it how many rows and columns you want to offset from it, and then you tell the offset formula how big that range that you want to use in the function should be. So we want to offset -1 rows from this I value, and we want to offset 0 columns. So basically we're after this cell right here, and then the height is going to be 1 and the width is going to be 1. So if this value here is a number, so that value is number equals true, let's just return true for now and false if it's not a number. So let's see what that looks like. And it screws up our calculations for the rest of the columns, but that's okay. I just want to show you how this works. So what this is saying is this cell right here is not a number, but in this row, this cell is a number. So that allows us to test whether or not we have numbers that we can actually calculate a range for. So now if this value is a number, we can go ahead with our calculations. So what we're going to do is just redo our formula again. So we're using offsets so we can keep this to table references only. What I mean by that is this is a table reference. So we're going to take the max of the offset of this value -1 rows. We're not going to offset any columns, and it's going to be a height of 2 cells. And close that off, and I'll just hit enter there so we can see what that looks like. So now you can see that if the value in the row above this one is a number, then it'll calculate the max of these 2 values. So the max of these 2 values is 51, and what we want to do then is take the max minus the min of the same thing. So offset from this value, offset -1 rows, 0 columns with a height of 2, take the min of that and enter. So now we have our moving range. And then instead of false, we just want to return blank, again, if that value above that, the previous value, is not a number. So we'll just hit enter. So now we can see that this returns blank, so it will not be included in our MR bar calculation. And then we have the MR calculated, and we're only using table references. And we're going to be doing that a lot. Hopefully everyone understands why. It adds a little bit of complexity to this, but it makes it so this is a very nice template that we can just drop any data into and it'll work. So now that we got that squared away, the next step is to set up our table so that we can do some conditional formatting in our chart. So in order to do that, the first thing we'll do is set up the conditional formatting columns for the MR chart. So we're going to set up 2 columns here for that. It's going to be MR in control, IC for in control, and MROC for out of control. And what we're going to do for that is we're going to test whether or not the MR value is less than the upper control limit. So we're just going to say if this MR value is less than the MR upper control limit, then we're going to return the MR value. And if it's greater than the upper control limit, then we're going to return an NA value. In other words, it's out of control, so we don't want to plot it as an in-control data point. And then we'll just do the opposite of that. Just copy that over, and we'll switch the operator to say if it's greater than the upper control limit, then it'll be out of control. The only thing here is that it's returning a blank value for that first one. So what we want to do is add another if statement to say if this value is blank, then return NA, and if not, then do our calculation. And we'll close that off and hit enter. And the reason we want to do that is because the chart will actually plot this blank data point as a 0 value unless we add that extra bit in there. So the next part is we need to set up a bunch of columns that are basically dummy columns that we're going to test certain things about the data. And then from these columns, we're going to be able to test whether or not the data point breaks a control charting rule. So this is going to be a little bit tedious, but it's the best way that I could find to do this. So the first thing we're going to have to do is test whether or not the I value, or the value of our data point, is greater than the mean. And again, this is all for the I chart. So if I is greater than the mean, we'll do a test for that. And the way we do that is we're going to say if the I value is greater than the I bar value, then we'll return 1, and if not, then 0. Enter. And it's going to format all these as percent, so we don't want to do that. So let's just switch numbers quick. So we're just basically returning a 0 or 1, and then we're going to test if the I value is greater than plus 1 sigma. And we're going to test basically where the data point is in the control chart. So I is greater than plus 2 sigma. I is greater than plus 3 sigma. Then we're going to test if I is less than 1 sigma. I is less than, oops, negative, forgot a sign there, negative 2 sigma. And then I is less than negative 3 sigma. So let's do the formulas for those. So if I is greater than the plus 1 sigma value, then we'll return a 1, and if not, then a 0. And I'm just going to copy these over. It's still formatting as percent, so we'll fix that in a bit. And then we're going to change the column reference to the plus 2 sigma, and then to the plus 3 sigma. Let's make sure to format these as numbers right away. Number, the decimals. Then we're going to test if the I value is less than the sigma levels on the lower half. So I'll actually just copy this over again, and we have to switch the operator to less than, switch the sign to negative, so we reference this negative 1 sigma column, and change this to negative 2, copy one more for the negative 3 sigma value. Okay, so now we have a test to see where our data point falls on the chart. And then the last thing we're going to test is if the data point is greater than the previous data point. And for this, we're going to use an offset again, similar to what we did for the moving range. So if the I value is greater than offset, we're going to offset from this I value negative 1, I value negative 1 rows, 0 columns, and then we don't need to add a height for it. It'll just default to 1. So if this data point is greater than the previous, then we're going to return a value of true, and if not, then false, and hit enter there. So now we have our tests, or our dummy columns that we can test from, and then from that we can create the columns that'll allow us to generate the conditional formatting from. So the first one is going to be for any data points that are greater than 3 sigma from the mean, and the formula for that will be if, and we'll use an OR statement to say if our I value is greater than 3 sigma, so equals 1, or our I value is less than 3 sigma, then we'll return the I value, and if not, then we'll give it an A value, so our chart does not plot it. And the formatting went back to the integer value, so let's switch that back to a percent. So once we change the formatting back to a percent, we can see that it returns the first 3 values in our data table, and that's because these 1, 2, 3 points are outside of our lower control limit. So these 3 data points would be greater than 3 sigma for the mean. So that is rule number 1 right there. The next control charting rule is if we have 9 in a row on the same side of the mean. Now this is where things get a little bit tricky with the offsets. We have to set up our formula so that it'll only test if there has been 9 in a row on the same side if we have 9 data points. So the reason for that is because if we set up an offset to go 9 cells above, say, this row, and there's not 9 cells above there, we'll get a reference error. So we have to first test to see that we have 9 data points here for us to be able to go back and calculate if 9 data points are above the mean. So actually we're working with this column here. So the way we do that is we're going to say if the row of the current row minus the row of, let's use the table header, is less than 9, then we'll return NA. And I'll hit enter there just so we can see what that looks like. So these first 1, 2, 3, 4, 5, 6, 7, 8 data points return NA because there's not 9 data points to calculate if this control chart rule is being violated. So once we've tested for at least 9 data points previous to this data point, we can test to see if there has been 9 on one side. And the way we're going to do that is we're going to take the sum of the previous 9 rows in this column, or the previous 9 cells in this column, and see if it's either equal to 0 or 9. Because if we have 9 points that are greater than the mean, then we have 9 in a row above the mean, and if it's equal to 0, then we have 9 points below the mean. So we're going to use another offset, actually do another if statement and an or statement. So if the sum of offset from this data point, we're going to go back 9 rows, 0 columns, and then we're going to make it 9 cells high. The sum of that equals 9, or, and then we'll just copy this, if the sum of that range equals 0, then we'll return the I value, and if not, then we'll return NA. Once we switch that to a percent, then we can see that this data point right here is actually the first of 9 in a row on the same side. And if we go back to our spreadsheet, 1, 2, 3, 4, 5, 6, 7, 8, 9 data points right here. This data point is the 9th data point on the lower side of the mean. So the third control charting rule or test that we're going to do is to see if we have 6 in a row. So 6 in a row, increasing or decreasing. And I've seen this as 7 in a row. The actual test or the rule is kind of up for debate, but usually 6 or 7 are the 2 most common that I've seen. I'm going to use 6 here. It depends on how certain you want to be about the control of your process, I guess. So I'm actually just going to copy this this formula over because the formula is actually very similar. The only thing we need to change is the number of cells we're looking at, so we want to make sure we have 6 data points to work with. And then instead of looking at the I is greater than mean column, we want to look and see if we have 6 in a row that were either greater than or less than the last. So instead of -8, we'll go -5, change this to 6 cells that we want to look at, see if that if the sum of the previous 6 data points is equal to 6, then that means that we had 6 in a row that were greater than the last data point. And then we also want to change this to that, and then same cell reference to see if the sum of the previous 6 data points is equal to 0. That means that we had 6 in a row decreasing. So if we hit enter there, you can see that right here we have 1, and sure enough, 1, 2, 3, 4, 5, 6 data points in a row increasing. So the fourth test that we want to do is to see if we have 14 points in a row of alternating increasing and decreasing values. So the way we'll do that is we'll add a column, 14 in a row, alternating, we'll just say. And how we'll do this is, again, we'll just copy this over because it's generally kind of the same thing we're going to be doing, only we need 14 data points to work with. And then instead of the sum, we're going to say if concatenate, you might need to use this formula, so we'll use concatenate, and then we'll say offset from this cell minus 13 points, 0 columns, and then we'll go 14 high. So we have the previous 14 data points. We're going to concatenate those. And if that concatenation, which just means combination of values just shoved together, if that equals the string value of 0, 1, 0, 1, 0, 1, etc. 14 times, so alternating from greater than, less than, greater than, less than, if it equals that string, or copy this, place this value here, or it's just kind of the opposite or the offset of that, or it equals that string value, then we'll know that we have 14 points in a row alternating. And in my data set, I don't have any, so I can't give you an example there. And then the fifth control charting rule is if we have 15 data points in a row that are less than 1 sigma level away from the mean. This is a test for under stratification. So if we have 15 data points in a row that are that tightly grouped to the mean, that means that our control chart is actually looking at too broad of a time range, and that we should actually break up the control chart to look at a narrower time range. So 15 in a row less than 1 sigma from the mean. I'm going to copy this formula over to here, and we're going to change this OR statement to an AND statement. We're going to look at 15 rows to make sure we have 15 data points. We're going to offset 14 rows for the first sum, and we're going to make it 15 rows high. Do the same thing here, and make it 15 high there. So instead of the mean, or the I is greater than mean value, we want to look at the I plus 1 sigma value to see if that sum is equal to 0. And then we also want to look at the I is less than 1 sigma value and make sure that equals 0. So if the sum of the previous 15 data points in both of these columns equals 0, then we know we have 15 in a row that are both less than 1 sigma above and greater than 1 sigma below the mean, if that makes sense. So hit enter there, and we can see that, again, this doesn't return any values. And I just realized I skipped a couple, so I'll insert 2 more columns. And your next rule should have been if 2 out of 3 data points are greater than 2 sigma from the mean, and then the one after that is if 4 out of 5 data points are greater than 1 sigma from the mean. So I'll just copy this formula again for the 2 out of 3 greater than 2 sigma formula. We'll look at the previous 3 rows, and then we'll change this I is greater than mean to I is greater than 2 sigma. Same thing for this value. And then we'll change our offsets, so we're only looking at the previous 3 cells, so minus 2, 3 high, and then we want to test if the sum of the previous 3 values in that column are greater than or equal to 2, and then change this offset as well, minus 2, 3 cells high, and see if it's greater than or equal to 2. Enter there. Now we can see this one does return some values. Oops, and I realized that I had one of the column references wrong. We want to look at if it's greater than plus 2 sigma or if it's less than negative 2 sigma. So hit enter there, and we get some more data points just to show you 1, 2, 3 data points that are greater than 2 sigma from the mean. So we can see that it plots a bunch of them because we had so many below the mean there, or below 2 sigma from the mean. Alright, so this one we can just copy over to the 4 out of 5 sigma here. We'll change this so we're looking back 5 cells. Change our offset, negative 4, 5 high, greater than or equal to 4 this time. Change our offset for the other column, 5 high, greater than or equal to 4. And then we got to change our column references. So instead of plus 2 sigma, we just want to look at plus 1 sigma and minus 1 sigma. So hit enter there, and then we have our column for that rule. And now finally for our last control charting rule. This one is going to be a test for if 8 data points in a row are greater than 1 sigma from the mean, and that's in either direction. So basically if it doesn't fall within plus or minus 1 sigma of the mean, and we have 8 of those data points in a row, then this control charting rule will be triggered. So the way we calculate this is I'll just copy this formula over. Once again, it's generally the same. I'll switch this 15 to 8, and I'm going to get rid of this and get rid of this other sum. And what I'm going to do is copy this offset formula to look at the plus 1 sigma column, and then I'll add one here to look at the negative 1 sigma column. Change this range to minus 7, 8 rows high, minus 7 rows, 8 rows high, and then I want to test if that equals 8. So what we're doing is we're saying if the sum of the previous 8 data points in this column and the previous data points in this column equals 8, so the sum of those two ranges together equals 8, then we'll return the I value. So hit enter there. Now we are almost done with the data table. So last thing we have to do is just add 2 more columns, one for the in control data points and then one for the labels, which will tell us which rules the control charting data point is breaking. So first we're going to do the labels column because the in control column is actually dependent on labels column. So in order to do this, we're going to concatenate, and we're going to say if is NA, and then we're going to look at each column for our control charting rules and look to see if they're NA. So if this value is NA, then we're going to return a blank value. But if it's not, then we're going to return a string of 1 comma. And we're going to do that same thing for each one of the control charting rules, only we're going to change the string that it returns. So you can see we're concatenating a bunch of conditional text strings to say if there is a value in this column, then we're going to return a value of 1 because that's the first control charting rule, and then so on down the line. So I'll just copy those for each one of the control chart rules. Okay, and then for the last control charting rule, we'll just do an 8. We don't need that extra comma in there. So then close off the concatenate function and hit enter, and we can see it builds our labels for us. So for example, this row right here is breaking the 1st, 2nd, 5th, 6th, and 8th control charting rule. And we'll use that to label our data points then. For this column, we'll just do an if statement to say if this column is blank, meaning it doesn't break any control charting rules, then we'll return the I value, and if it's not blank, we'll return an NA value. So then we can see it plots our in control data points. So now to update our chart, we just have to add these columns to the chart data. So we'll go back to the chart and hit select data, and then we'll add a range to this chart data, and we'll copy this range here, copy that over, and change it from range or column X through column AF. So from here to here, and that'll be all of our conditionally formatted columns. If we hit OK, it adds all of those data series to the chart then. And it doesn't exactly look right, so what we have to do is reformat this so it looks how we expect it to. So the first thing we have to do is we have to right click and hit Format Chart Area, and then I'm going to select the series I, and I'm going to take away the markers. So we'll just have a thin line running through all of our data points then. So we'll hit None on the marker options, and then we want to format each of our conditional data series. So I'll select the points that are greater than 3 sigma from the mean or outside the control limits. And what we'll do is we'll say no line, but we'll add markers so we can see those data points. I'll use this round marker type, and then we'll give it a size of 7 with a red fill and then a black border. So now you can see it formats all those data points that are outside the control limits with red. And then we'll use this drop down again to select our other control charting rules, and then we will give those a different format because they're inside the control limit, but they are breaking control charting rules. So we'll say no line again, give it a built-in marker type, give it a solid fill, and this time we'll do orange for those data points, and then give it a black border. Now you can see we're starting to get somewhere. We'll do that same thing then for each of the other control charting rules, but you can see once I did that, it actually overwrote the red data points because of the way we have our data ordered. So I'll go to select data and then find the greater than 3 sigma from the mean data series, and then we'll move that down to the bottom. So that way it always shows over top of the other control charting rules. So again, just go back to this drop-down list, select each of the control charting rule data series, and then format them with no line and a marker with solid fill. And then for the in control series, we'll again give it no line, but we'll make the marker green instead. So now we have this conditionally formatted control chart. For the MR chart, we'll again just select the data, and we'll add that range for the conditional columns. So it'll be range N through O, so I'll get those 2 columns in there. So again, just copy this range here, switch this from N to O, hit OK, it adds those data series, and then just reformat. We'll take away the markers on the MR value, and then again for the in control values, we'll give it a green fill. And take away the line. Out of control values, take away the line, and give it a red fill. And there you have it. There is our control chart with the conditional formatting, but the last thing we need to do is add data labels. So now to add data labels, we have to be very careful to select the I series, make sure we have it selected here, and then go to this plus symbol to add chart elements, and then add data labels, so check that box. But then we want to go to more options here. Under the label options, we want to uncheck the value box and check this value from cells, and this will allow us to select a range that will be our data labels. For that range, I'm just going to select this entire column, but not including the very first row. We don't want to include this value here in our data label range. Hit OK there, and we can see it added data labels. And that got a little cluttered, so what I'll do is I'll just shrink the size down a little bit. That should help, and then maybe I'll move them below. And that maybe helps a little bit. It's cluttered down here, but typically in a control chart, you won't have so much going on. As I said in the comment in the last video, this is not good data for a control chart because it's obviously very out of control. There's data points all over the place that are out of control. So this wouldn't even be something that you can monitor with a control chart. But it is a good example just to show the conditional formatting and how that works. So that's why I chose this data set. Now I just want to reiterate the fact that this control chart is now dynamic. So if I just add a row here, go to the next day and I add a value of say 50%, go back to our chart, you can see that everything updates dynamically. So it added those data points. You can see the MR value was out of control, and then also the I value here was outside the control limits, so that formatted red and added that data label for breaking that first control charting rule. So one last thing, kind of a bonus, I didn't say I was going to do it in the last video, but we can add another column here, and what I'm going to do is I'm going to call this group. So a lot of times in control charting, we want to compare different time ranges to see if there's a change. So what we can do is within our data table, we can add groups so that it will calculate control limits and sigma levels separately between two time series. And you'll see what I mean here in a second. So I'm just going to reformat that. And I'm going to take this and fill it down, everything 1, but then halfway down, I'm going to change it so we have a group 2. So what this has done is it's separated this range of time separate from that. And then when we change some formulas to look at these groups, then these will calculate separately. This will make sense in a second. Instead of average, we'll say if this group value equals that entire group range, then we'll average the I value, and if not, then we'll return a blank value. Close that off and hit Control-Shift-Enter, and now we can see we have two separate I bar values. And then we'll have to do the same thing for the MR bar value, so we'll say if this group value equals the group range, then return the MR value to the average function, and if not, return a blank value. And hit Control-Shift-Enter again. So again, what that's done is it's calculating the I bar and MR bar values based on the group number. So if we go back to our chart, we can see that there are two separate time frames where we're setting the control limits. So everything calculates separately based on how we group the data. So just kind of a bonus little tip there, kind of interesting. So you can compare two different time intervals to see if there was a change.